Hey math kids, today we're going to talk about simple rules of differentiation. And yeah, so we went through differentiation using the initial principles, and now we're going to learn some shortcuts essentially. So, some just real quick ones. If we have a constant, the derivative is just zero. And remember, because derivatives describe change, and since a constant does not change, its derivative is zero. So for example, if I said find the derivative of 3, the answer would be 0. Okay? Now, if we have x to the n, the derivative is going to become n x to the n minus 1. So an easier way to think of that is like if we have x cubed, we bring that down in front, and then we reduce the exponent by 1. And so this would be the derivative. Okay? Now, if we have a constant and a function, the derivative of that, we keep the constant out in front, and then we just take the derivative of whatever. So, for example, if we had 4x cubed, using this rule, so we would just keep the 4, then we'd bring the 3 down, and then reduce the exponent by 1. And so the final answer would be 12x squared. Okay? And then if we have u to the x, or u of x and v of x, and we add them together, we just take their derivatives separately and then add them together. Okay? So for example, if we started with this plus this, that would become this plus this. And then, of course, if we can simplify further, which we can in this one, we'll just combine like terms, and that would be our final derivative. Okay? Which, if you notice, if I added these before I took the derivative, we bring the 3 down, and so that's 15x squared. So it doesn't matter which order you do that in, it still worked out. Okay, now I'm just going to go through the examples in the book for this section and see what happens. Okay, so we have 5x cubed plus 6x squared minus 3x plus 2. And so all we need to do is we bring down the exponent, so 3 times 5 gives me 15, and then I reduce that 3 by 1. Bring this down, 2 times 6 is 12, and then reduce that by 1, so it's just x. This is a 1, bring it down, so negative 3. Then the x would be x to the 0, or it goes away. And then remember the constant, or a derivative of a constant, is 0, and so we don't need to do anything with the 2. And so that is the derivative of the blue thing. Okay, 7x minus 4 over x plus 3 over x cubed. Okay, before we take the derivative, I'm going to rewrite this like this. So using negative exponents. Now when I take the derivative, that just becomes a 7. This, I bring the negative 1 down, so that becomes positive 4, because I'm just multiplying those. And then we reduce it by 1, so it's x to the negative 2. Bring down the negative 3, we get negative 9. Negative 3 times 3 is negative 9. X, and then we reduce that by 1. And then we end with that. And then I'm going to just put it back in the same form as up there. So the 7 is fine, but this would be 4 over x squared minus 9 over x to the 4th. Now if we have 3 times square root of x plus 2 over x, when we do that, once we want to do kind of what we did over here where we rewrite it. So it's 3x to the 1/2 plus 2x to the -1. And then we just go through that same process. So bring this down. 3 times 1/2 is 3/2. 1/2 minus 1 would be -1/2. And then bring this down, we get -2x to the -2. And then we want to write it without negative exponents. And so I'm going to get 3 over 2. And then this is a square root of x, but on the bottom of the fraction, minus 2 over x squared. Okay. All right, let's get some room over here. And we start with x squared minus 4 over the square root of x. Once again, to take the derivative, it's a little bit easier if we rewrite it. This would be x to the -1/2. And then we go through the process. So we bring the 2 down, reduce this by 1, bring the -1/2 down. So it's going to be positive 2, because half of 4 is 2. Then we get x, and then if we reduce this by 1, we get -3/2. Okay, now we don't want those negative exponents, so we get 2x, and then 2 over x to the 3/2, and then we could even take that a little bit further and say 2x plus 2 over the square root of x cubed. So either of those will work for me. I don't really care which one you do, but just do that. Do one of those. Okay, now they want us to find the slope or the gradient, how your book words it. So let's get that there. Okay, so they want us to find the gradient of the tangent to this. At x equals 2. So what we're going to do is we're first just going to take a derivative. We're not going to worry about the x equals 2. So I'm just going to rewrite it in a form that makes it easier to take the derivative. And then take the derivative. And then I'm going to write it like this. Okay. So this is our derivative function. Now this will tell us the slope of this function at any x value. So all we have to do now, plug in the x value. So that becomes 4 plus 4 over 4, which that's really just 1, and so 4 plus 1 equals 5. Okay, so the gradient of this function at x equals 2 is 5. Okay, and we just have one more example. So we have y equals 3x squared minus 4x, and it says find dy over dx and interpret its meaning. Okay. So to find dy dx, that's just another way of saying find the derivative function. So we bring the 2 down, 2 times 3 is 6, reduce the exponent to a 1, don't need to write that, and then hopefully you're picking up, if it's just a number in front of x, the derivative is just that number, but technically we're bringing the 1 down, multiplying it by -4, and then it's x to the 0, which is 1, and then 1 times -4. So if you really want to think your way through it, you can, but I think picking up on the shortcut that if we just see this It's just that number out in front when we take the derivative. Okay. Now, this is our y prime, or our dy dx. So that answers the question. And then it's just asking us, what does this really tell us? And it's on the previous problem, I explained it. This tells us the slope everywhere on this. So if I plug in a 5 for x, it tells me what the slope is at x equals 5. So if we have a curve, this isn't necessarily that curve, right? Because that's a parabola. Maybe I'll do a parabola. And so we plug in a 5. What this function will tell us is the slope of the tangent line at that point. Okay, if you need additional help, please come to Math Lab. Until then, calculator.